Welcome back, everybody. I don't have anything funny to say. Cool. All right. So yesterday we saw this trick, sure, for lack of a better word, where we're factoring quadratic-looking things that really don't look super quadratic to begin with. And just as a reminder, this looked awful originally, and then we just simply said, hey, notice that this is something squared and something to the first power, and it looks like a quadratic essentially. We then can use, and I'll probably only do it on this one where I physically substitute something in as a placeholder, but it makes it a whole lot easier. And we stopped here. We got u minus 3 and u minus 4. Now, we used e to the x as our u this whole time. When we solved this one, we got x equals the natural log of 3. It's just an ugly what? Number, but it's just a number nonetheless. Okay, so I get x equals the natural log of 3. What do we get from the other factor? It's gonna be the exact same work, just with a different number, and I'm gonna wind up with x equals the natural log of 4. Do you agree with that? Do you want to see the work that gets me to x equals the natural log of 4? Okay, so we're done, and we have it. Now, we won't typically check these like on calculators and stuff, but we can. Will you guys do me a favor? Will you, with a calculator, one person give me the natural log of 3 and the other person give me the natural log of 4? And we're going to see if this, in fact, agrees with, rather, the graph of this function. So we have e to the 2x minus 7e to the x plus 12. So here's my function, and I have the sneaking suspicion that the natural log of 3 is probably 1.09861. Can somebody verify the natural log of 3 is that? And I bet the natural log of 4 is probably 1.386. Yeah. Hey, look at that. These are the roots of this wonky, quadratic-y looking weird guy function. It works, and it works well. There are other techniques that we could use. I wouldn't. That's the technique that I think we should use, because it's so much easier to factor a quadratic, because we spent a crazy amount of time factoring quadratics. All right. Another one together. Do you guys want to try one of these on your own? Okay. Now, when I say on your own, just a reminder, it doesn't mean that you have to do it completely in isolation, right? Cool. I'm going to give you guys a head start on it, and let's do another one. So this was a quadratic type. All right. Here we go. On B. Jumping in, we'll try to use the same color. B. We have e to the 2x minus 9e to the x plus 20 equals 0. Okay, I'm going to try to do this. I'm going to try to hide my screen from you guys, and I'm just going to start working it. I want you guys to work it with one another. If you use a u substitution trick, can we all agree just real here and now, what is u? It's e to the x again. When you see my work here in a moment, I will not do a substitution trick. I'm just going to keep it e to the x because I'm more used to it than you are. Like, no other reason than that. Cool. Do it to it. I'm going to hide my screen for a moment.